Okay, start from -4, and when x equals to 3, from the equation dy dx will be 6. Okay, so what's happening is I have a straight line like this. Okay, and because this point is included, so the ending point is included. Okay. However, okay, the important point is still here. Okay, when x equals -2, okay, from the graph there, we can find the differentiate the gradient is -4. But however, okay, because in the function, in the gradient function, it is not the gradient function is not it's not a continuous function. So again, this point is not defined. When x equals 2, dy dx is not defined, because we calculated the value here, approximately the value where we assume it is, and when we look at the gradient function graph, it is not a continuous graph. So again, we use we have to put open circles at the point when x equals -2 in the gradient function graph, okay, because it is not defined. Okay, and simply because it's not a continuous function. It is a continuous function. In the original function is continuous, but because the gradient function is not continuous, so this point again is not defined. Okay, so it's very similar to here. In question A, the original graph is not a continuous function, so at the point of joint, dy dx is undefined. We have to put an open circle there. Okay. Similarly here, the gradient function of the gradient function of the the gradient function is not continuous. So again, at the point of joint, it is undefined. Okay, let's look at question E. So from the log of question E, I can say I have a continuous function there. Okay, but because okay, from the graph I can say at the point of -2, dy dx is not defined. Because in the gradient function is not continuous. How do I know? Is I say a very sharp corner there. Okay, we can try it. Is basically the gradient of this part is a positive number. M is positive 6. Okay, positive 3 and 2 from the reading of the graph. So until -2, I draw a circle there, open circle. Okay, and let's find the parabola. The parabola is y equals to x squared, dy dx is 2x. Okay, I will have a straight line like this. Okay, until the point 3, 6. Okay. Again, this part, the continuous graph is not sorry, the gradient graph is not continuous, so we put a circle circle dot. Well, we put a circle dot, open circle dot at the point of the joint, which is x equals to -2. Okay. Okay, this is simply because when x equals to -2, the dy dx is undefined. We don't know what the gradient of the graph is, okay, and we can't calculate it from there, because at the left hand side the gradient is 2 and 3. At the right hand side of the point -2, the gradient is let me say -4. So okay, and if someone asks me what's the gradient at x equals to -2 of this graph, I can't tell them. There are two values, and both of them are not right, are wrong. Okay, and let's say question F there. Okay, in question F, I have a straight line there and a parabola. Okay, so let me do the same thing. From -4 to 2, let me find the gradient of this straight line first. The gradient is rise over run, rises 8 unit, runs by -2 unit, so the gradient is -4. Okay, so at the point of -4, I draw a straight line. Okay. Here. Sorry. At the point of joint, I draw open circle. Okay, there, and this line is y equals to x squared, labeled here, and the differentiate is 2x, and when x, okay, I have to find the starting point of the straight line. When x is -2, dy dx from the graph here is -4, so which I have a match from here, and I will draw a line, okay, which is 3 here, and my dy dx will be 6. Okay, in this graph I can say, okay, the gradient graph is continuous, so at this point there I put a dotted circle. Okay, only in this graph, when both the original graph and the gradient graph is continuous. Okay, so the point of joint, when x equals to -2 in this case, the differentiation of a point when x equals -2 is defined, which is -4. Okay. To simplify it, when they ask you to to do this kind of question, remember to put a open circle in your answer if either the original graph or the gradient graph is not continuous. Okay, if both of the graph are continuous, put a black, well, put a full colored dot at this point, means the point is included. Okay, and this point, the differentiation of this point is defined. Okay.